The Rust Standard Library contains several collections. These are generic types for storing data in memory. So throughout this section, I will introduce a few of these common collections to you, but just so you're aware, there are more collections available than what I will be going through. But let's start off with one that we are already familiar with, and that is vectors. So let's start off by looking at vectors and look at some of the methods that are associated with the vector. So we'll create a mutable vector called nums, and we're going to just put in values of i32, and we want our vector to be empty to start. So we saw this earlier in the course. We can use a push method to add values into the vector. So let's do that. And let's just add in a few values here. So one way that we can remove values off the top is by using a method called pop. And this actually returns a value. So we can actually say let pop equals num.pop, and then we can print out this value. Does not implement, so there we go. So now we can run this, and we can see that we returned sum3. So this returns an option of type t. So remember, this can either return none or sum_t. And in this case, it popped sum3. So think of this as a stack of plates. So we're going to push plates onto the top, and then when we pop, we want to take off the last plate, so in this case 3, that we pushed onto the stack. So we can also, just as a review, reference some of the numbers. So we can say let 2 equals num1, and since we're doing i32, this would just be a simple copy. But if we were doing another value that doesn't implement copy, we could create a reference to it in this case. So creates a reference if copy is not available. And then just to show you that we were able to successfully copy it, we'll say 2, and we'll run it, and we got 2. So great. So there's a couple of other ways that we're able to return values. One of them being let 1 equals num.first. And as you can imagine, this is going to return to us the first value in our vector. But again, this is going to return an option t. So it's going to be none if the vector is empty, or sum_t if the vector is not empty, because we're going to take out the first index. So we want to return we want to get the first value. So let's make sure that 1 successfully did just that for us, so 1. And we returned sum1, which is great. That's the expected value that we were anticipating. So we can also do dot last, and just like first, instead of it being first, this is going to return the last value in the vector. But we also have dot first mute and dot last mute. And kind of as the name suggests, it's going to be the same as first and last, but it's going to borrow mutable references. We'll borrow mutable references. So if we want to check out the length of our vector, we can do nums.length, len, short for length, And then if we want to do a quick check to just see if our vector is empty, we can do nums dot is empty, and this is going to return a Boolean, whereas this will actually return a value of the length. Another way that we can add values inside a vector is using insert, but insert's going to allow us to insert at the index of our choice. So we can say insert at index 0, so the first index, and we want to insert 10. But we can also say nums dot insert at 3, and we'll put in 12, and then we can do nums dot insert 2, and we can put in the value of 25. So, like insert, we can remove with nums dot remove, and then we can just specify the index that we want to remove. So in this case, let's remove index 3. And then if we want to sort everything out, we can do nums dot sort. And now let's look to see how it would appear sorted, just to make sure everything looks good. And now we're going to do nums. So we run it. We see we have 1, 10, 12, and 25. Looks sorted to me. And we can also run a method such as reverse, which is going to do what we expect it to do, which is just going to reverse this. So in this case, since we already sorted it, I expect it to be 25, 12, 10, and 1, which is great. That's exactly what we got. So something else that we can do is we can actually have our vector shuffled. So in order for us to do this, we need to go into our cargo.toml file, and we need to specify that we want to bring in the rand package. So we're going to say rand, and then we're going to do version 0.8.4, which is the latest version of rand at the time of this recording. We'll save that file, and then we'll come to the top outside of main, and we're going to say use rand seek and slice random, and then we're going to say use rand thread RNG. And now down here we can say nums.shuffle, and it's going to say want a mutable reference to the value generated to us by thread random number generator. That is what RNG stands for. And now if we print this out, it's going to shuffle our vector for us. And we'll run this a couple of times just to make sure that it is being shuffled. And we got 10, 25, 1, and 12. And then we got 12, 1, 25, and 10. And then we got 10, 12, 25, and 1. So it does appear to be shuffling as we intended. So these are just some examples of what vectors have to offer in Rust. There are many more methods we can use, so I do encourage you to play around with all the methods associated with vectors. That way you become familiar with all the methods we have at our disposal. So now we're going to talk about a binary heap. A binary heap is a collection whose elements are kept loosely organized. The greatest value always bubbles up to the front. There are 3 methods commonly used with the binary heap, and they are push, pop, and peek. And those are going to be the 3 methods that we look at. So let's start by bringing in a binary heap into our scope by calling standard collections binary heap. So now we can create a mutable B heap by saying binary heap new, and that's going to instantiate us a new binary heap. And now, like what we did with a vector, we can push values onto here. So let's push in multiple values just to make sure that our largest value is always bubbling up to the front. So now let's print out the binary heap and just make sure that 20 is at the front. And that's exactly what we got. Awesome. So the behavior is working as expected. So the first thing, we saw that in vectors, but we can also do pop. And what this is going to do is it's going to take off the value at the front. So if we run it again, we expect 20 to be gone, but now we expect 18 to be at the front, which is great because that's exactly what we got after doing it. But one method that we can use is called peek. And what peek is going to do is very similar to pop, but instead of us getting a returned value and instead of the value being removed from the binary heap, peek is going to leave the value there for us, but it's still going to return that value to us. So when I run this now, I expect 18 to be returned. So peek is going to return an option t, and then obviously return none if empty or sum t otherwise, which is great because that's exactly what we got. But just to make sure that the value wasn't removed, let's print out our B heap again, and great, we still see that 18 is at the front. So again, the difference between peek and pop is that peek is going to leave the value inside the binary heap, whereas pop is going to actually remove the value and return it to us. So again, a binary heap is not too difficult, but this collection is useful in cases where we care about priority. So as we add values in, the higher the priority, obviously it will be at the front of the binary heap, which is going to allow us to take care of whatever has the higher priority first. A map is a collection of key pair values. No entries can have the same key, and when you want to look up an entry, you just need to know the key for a quick lookup. Rust gives us two types of maps, hash map and a B-tree map, also known as a binary tree map. These two maps are very similar. The key difference is how the two maps keep entries arranged for their lookup. Hash maps are stored in a single heap allocated table, whereas B-tree maps are stored in a tree-like structure growing from the top down into many leaves, also called nodes. I don't want to get too into the data structure setup behind these, but I do want to point out that I eventually plan to add a data structures section to this course to where we can see how data structures are set up and then also improve in our Rust skills. But again, these two maps have very similar methods, so I am only going to create and use a hash map, but it is similar to a B-tree map. So the first thing we need to do is bring a hash map into our scope, and it's going to be in standard collections hash map, as was the binary heap. And now we can create a mutable hash map using hash map new. So like a B binary heap did, we have the len method for length and the isEmpty method as well, which is, remember, going to return a Boolean on if there are values or not in there. So let's add a couple of values using the insert method, which, as you can see, it's going to accept two parameters, the key and the value, designated by K and V. And so we can both see that they are generic types. So let's add in a key of 1 and then also a value of 1. So then we can add a couple more in, and we'll say insert 5 and 2, and then we'll say insert, and we'll give a key of 30 and a value of 3. So now let's print out our hash map just to kind of see how it is structured. Cargo run, and we can see that we have 1 to 1, so key 1 value 1, key 5 value 2, and then key 30 value 3. So now earlier I mentioned that you cannot have multiple values mapped to a key. So what happens if I say at key 30 I want you to have the value 4? Because we can see that the IDE does not give us any error codes, so it looks valid. Well, what's actually going to happen here is the key is going to update the old value of 3 to the new value of 4. It's also going to return the old value. So we can actually say let old equals and then to the insert. So now if we come down here and we try to print this out, and we'll say we want to print out the old value, and now if we run this, we see that the key of 30 updated to our new value of 4, and then we got the old variable was assigned sum 3. So it's also going to return an option of type T. So great. So we're able to actually update values using the insert. That way we don't generate any bugs trying to insert a value at a key that already exists. So we can check to see if a key exists using the contains key method, and that looks like this, and we can see that it is looking for a reference to a key value. So in this case we'll say a reference to 5, and if we run this we would expect true to be printed out, which is what we got. So if we reference a key that does not exist, such as 8, false is returned. So that's great. So now we can check to see if keys exist inside of our hash map. But how about getting values back? So we can say print, and then we want to print out the value of the key, and we'll say key 5 again. So when we run this, we expect 2 to be returned, and we get sum 2. So we are returned an option of type T. So that that means that if that key does not exist, then none would be returned. Otherwise, we are going to return sum T if that key does exist. So now we have 2 ways that we can remove values. The first way is remove, and we're going to pass in the key that we want removed. So in this case we'll pass in the key of 1, and if we now print out our, and I'm just going to copy this, if we now print out our hash map, we expect the 1 to 1 to be gone, which as you can see, so it's up here when we create it, and now down here our key of 1 and value 1 is gone. But this also returns the value for us. So if we run it this way, then we see we get sum 1 returned. So it does return a value if we decide to do it that way. Now another way we can do it is we can say remove entry. So we also get a returned value from this, but it is a returned pair value. So remove entry is going to actually return the key and the value. So let's remove the key of 5 and make sure that the key of 5 is returned as well as the value. So we can see that we are returned the key of 5 and the value of 2, which is what we initially inserted in. So the difference between remove entry and remove is that remove entry is also going to return the key alongside the value, whereas remove is only going to return the value. And then if we quickly want to clear out our hash map, we can use clear. And then to verify that this was cleared out, we can use our method isEmpty. And since we ran clear, we would expect this to return true, which is what we got. So these are just some of the methods associated with the hash map. Again, a B-tree map and a hash map are extremely similar. So I encourage you to create a B-tree map and then just basically do what we did here, just to make sure everything works the same and that you are also familiar with how a B-tree map works. Sets are a collection we can use for quickly checking if a value exists. A set can never contain multiple copies of the same value. Maps and sets are different, but when you look behind the scenes, a set is similar to a map, except a set is only going to have keys and not a key pair value like a map. So, like maps though, there are two sets Rust give us, a hash set and a B-tree set. And again, hash set and B-tree set are similar, so I'm only going to show you how we can use a hash set. So let's start out by adding the hash set into our scope. And now we can come down here and we can create a mutable hash set with the new keyword. And like a hash map, we can have length to return how many values are in our hash set, as well as isEmpty to return a Boolean on if our set is empty or not. So, just like a hash map, let's begin adding in some values with the insert keyword. And we'll add in our values. And in this case, we'll just add in 1, 2, 3, and 4. And 4. So to print this out, we can use what's known as an iterator. And we'll be able to talk a little bit more about iterators a little bit later in this course. But we can do for x in hs.iter. Now we just want to print line iter and x. So now if we run this, we'll see our iterator, and I'm going to get rid of this in because that'll bother me. But we have 1, 2, 3, and 4, which is what we added in. So that's awesome. To remove a value like we did in a vector, we can just say, hey, we want to remove a reference to the 2, and then up here we'll actually cut and paste this, run it again, and now we only have 1, 3, and 4. But I'm going to comment that out just to keep our values in there. So now I'm going to create another hash set called hs2, just for hash set 2, and have it be new. And then I'm going to come down here, up here, and let's say 1, 3, 5, 1, 3, 5, and 7. And then obviously we need to change these to hash set 2. So now we have another hash set with the values 1, 3, and 5 in it. So now with sets, we are actually given some new methods. So, and the first one we're going to talk about is intersection. And when you check intersection within two sets, you're going to see which values are in both sets. So the first way we can do this is say for x in hash set dot intersection, and then pass in a reference to the second hash set, and now we can print line, and we're going to say intersection x. And so we see we have 1 and 3 in both sets, and intersection has printed out 1 and 3 between the two sets. So another way that we can do this, a more shorthand way, is we can actually say let intersection equal to a reference to the first set, the binary bitwise AND operator, so the ampersand sign, and then a reference to the second set. So now intersection is going to be a set that's going to contain the values that are in both sets. So let's print that out. For x in intersection, print line, and then we're going to say shorthand way, and now x. And we expect this to still be the same results of 1 and 3, which is what we got. So this is a shorthand way, shorthand intersection, using the bitwise, the binary bitwise and percent operator. Another one that we have is union. And union is going to return values that are in either the first hash set or the second hash set. So I'm only going to show you the shorthand way, because otherwise it's going to be the same way above. Instead of it being hash set, then method called intersection, our method call would be union. So let's do our shorthand way and say a reference to the hash set with the binary OR operator, and then hash set 2. So now union is going to be a set that's going to contain values that are in either of the two hash sets. So let's print this out to make sure that we got the correct values. Union and then x, and for union in, there we go. And now if we run this, we have union 1, 2, 3, 4, 5, and 7. So we can see that we didn't have duplicate values of 1 or 3, but we have all the values occurring once between the two sets. And then lastly, we can do the difference. So likewise, difference would be called like this, but we're going to do the shorthand way and say let diff equals a reference to the first hash set minus, so the difference between the second hash set. And now we can print this out and see what the difference is. And we'll say diff and x. And so with the difference, we want to see what values are in the first hash set but not the second hash set. So if we run this, we see that we have 2 and 4, and that would be correct because we have 2, 4, and then in the second hash set we do not have 2 and 4. So there are more methods we can use on a set, but these are some of the main ones, and as you can see, we can do a lot of logic handling very quickly on sets. Again, these are just some of the collections we have available to us in Rust, so feel free to check out more collections. But again, later on down the road, I do plan to show how we can create some of the data structures available to use in Rust so that we can continue to learn and become more proficient in our Rust journey.